When you first learn about containers, it is easy to focus on images because images feel like the thing you can hold on to, name, and reuse. But the moment you actually run a container, you shift from templates to living behavior, and that is where many beginner questions appear. Why does the application behave differently in a container than on the host? Where do you see what it is doing? And how do you look inside without breaking the idea of isolation? At exam level, you are not expected to be a full-time container operator, but you are expected to understand the common tools and concepts people use to manage running containers and to reason about their purpose. In this episode, we focus on 5 practical ideas that define the running container experience: environment variables, logs, exec-style access, inspection, and the reasons you would use each one. The big goal is to separate intent from habit, meaning you should understand why a technique exists and what problem it solves, rather than just remembering that it is something people do. Once you can explain what each tool concept is for, you can interpret scenarios about container behavior without defaulting to guesswork. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Environment variables are one of the most common ways to influence how an application behaves inside a container without changing the image itself. An environment variable is a key value setting provided to a process at startup, and applications often use these settings to control things like connection endpoints, feature flags, logging verbosity, and operating modes. Containers make environment variables especially important because the whole goal is to keep the image generic and reusable while allowing the runtime configuration to vary by environment. For example, the same image might be run in a development environment and a production environment, but it needs different settings in each place. By using environment variables, you can inject those differences at runtime without rebuilding the image. A beginner misconception is to treat environment variables as secret storage, but while they can carry sensitive values, they are not inherently private, and their exposure depends on runtime and host controls. At exam level, remember that environment variables are configuration inputs, not code changes, and they allow the same image to behave differently across contexts. The most important reasoning point about environment variables is that they live at the boundary between the container runtime and the container process. They are not permanent modifications to the image, and they do not automatically persist across different containers unless you supply them consistently. This is why 2 containers created from the same image can behave differently if their environment variables differ. It is also why a container might work in one environment and fail in another, even though the image name is the same. If an application inside the container expects a required variable and it is missing or wrong, the container might start and then exit quickly, or it might run but fail to connect to a backend service. A calm troubleshooting mindset treats environment variables as one of the first places to look when behavior differs between runs. From an exam perspective, environment variables are a core part of container configuration because they keep images portable while still allowing customization. If you keep that portability goal in mind, the concept becomes intuitive. Logs are your main window into what a running container is doing, especially when you cannot or should not interact with it directly. Containerized applications often write output to standard output and standard error rather than writing logs to a file inside the container, and container platforms treat that stream as the primary logging interface. This design supports the idea that containers are disposable and that the host or platform should capture and manage logs centrally. For beginners, the key idea is that logs provide a record of application behavior, including startup messages, errors, warnings, and operational events. If a container starts and then crashes, the logs often show why, such as a missing configuration, a failed dependency connection, or a permissions issue. If a container stays running but is not functioning correctly, logs can reveal internal errors even when the process itself is alive. At exam level, logs are the evidence trail, and knowing that containers typically log to output streams helps you understand where to look. It is also important to understand what logs are not, because beginners sometimes expect logs to be a perfect, complete truth. Logs reflect what the application chose to record, which means poor logging can hide real problems, and overly verbose logging can drown you in noise. Logs can also be affected by configuration, including environment variables that increase or decrease verbosity. Another key point is that logs are separate from interactive troubleshooting. You do not need to attach to the container to get logs, and in many operational models, you avoid interactive attachment because it changes the running environment and can interfere with automation. The logging approach reinforces the idea that containers are meant to be managed from the outside, with observable behavior rather than hand-tuned interiors. For exam questions, if you see a scenario about diagnosing why a container is failing or exiting, logs are usually the first source of clues. The container might not be alive long enough for you to do anything else, but it can still leave logs that explain the failure. Exec-style access is the concept of running a command inside a running container without rebuilding it or restarting it. Beginners often imagine that containers are sealed boxes that you cannot enter, but in practice, administrators sometimes need to look inside to confirm a file exists, check a process list, or test connectivity from the container's perspective. Exec provides a way to do that while the container continues running its main process. The key mental model is that exec does not turn the container into a virtual machine. It simply starts an additional process inside the same container environment. That means the process sees the container's file system view, network view, and environment, which is useful for troubleshooting because it matches the application's context. At exam level, exec is about diagnostic access and operational checks, not about normal application management. If you treat exec as an emergency flashlight rather than a standard workflow, you will keep the container model consistent. There are also risks and misconceptions around exec that matter for clean container thinking. If you use exec to make changes inside the container, like editing files or installing packages, you are changing a running instance in a way that is usually not captured in the image. Those changes can disappear when the container is replaced, and they can make behavior inconsistent across replicas. Exec can also create a false sense of permanence, where a fix seems to work but cannot be reproduced because it was done interactively rather than by building a new image or adjusting runtime configuration. From an exam mindset, the safe reasoning is that exec is for inspection and short-term debugging, while durable fixes belong in image builds or controlled configuration inputs. If you see a question that contrasts temporary troubleshooting with long-term maintainability, exec fits the temporary side. Understanding that distinction helps you pick the answer that aligns with container best practices without needing deep operational experience. Inspect is a different kind of tool concept because it is not about going inside the container. It is about reading the container's metadata from the outside. Inspection answers questions like what image the container came from, what environment variables were provided, what network settings were applied, and what storage mappings exist. This is extremely useful because many container problems are not caused by the application itself, but by mismatched runtime configuration. If a container cannot reach a service, the issue could be network configuration, and inspection can reveal what network mode or port mappings are in effect. If an application seems to use the wrong endpoint, inspection can reveal environment variables that differ from what you expected. If data is not persisting, inspection can reveal whether storage mappings are configured or whether the container is using only its ephemeral writable layer. At exam level, inspection is the bridge between your mental model and the actual runtime reality, giving you concrete answers about how the container was launched. It supports evidence-based troubleshooting in the same way that status and logs support systemd troubleshooting. The most helpful way to compare logs, exec, and inspect is to see them as three viewpoints on the same running object. Logs show you what the application is saying and doing over time, which is behavioral evidence. Exec lets you run a diagnostic process inside the container, which is contextual evidence from within the container's world. Inspect shows you how the container was configured from the runtime's perspective, which is structural evidence about its settings and connections. Beginners sometimes reach for exec first because it feels like the most direct access, but that can be the least controlled approach. A more disciplined mindset often starts with logs and inspect because they do not disturb the container's interior and they reveal configuration mismatches quickly. Exec is then used when you need to confirm something that only makes sense from inside the container's view, like how name resolution looks or whether a file exists at runtime. This ordering is not a strict rule, but it reflects a preference for non-invasive evidence before interactive intervention. For exam questions that ask what you would use to diagnose or verify a configuration detail, inspection is often the correct concept. Environment variables also connect back to logs and inspect in a useful loop that helps you reason about cause and effect. If a container is failing, logs might mention a missing configuration or a connection attempt to an unexpected destination. Inspection can reveal whether the relevant environment variables were set correctly, and if they were not, you have a clear explanation of the mismatch. If the environment variables are correct but the behavior still fails, exec can help you test from inside the container context, like verifying that the container can resolve a host name or reach a network endpoint. This loop is a clean troubleshooting story because it moves from symptoms to configuration to contextual verification. You can use the same reasoning even if the container platform or tooling changes, because the concepts remain the same. The exam is not trying to trap you with brand-specific trivia as much as it is trying to see whether you understand the relationships. When you can articulate that loop, you are operating at the right conceptual level. To wrap up, running containers is where configuration and observation become more important than the image itself, because runtime settings shape how the application behaves in the real world. Environment variables are a primary way to provide configuration at startup without changing the image, allowing the same image to be reused across different environments. Logs are the behavioral evidence stream that reveals what the application is doing and why it might be failing, often even when the container exits quickly. Exec provides a way to run diagnostic processes inside the container's environment, which is useful for troubleshooting but should not be relied on for durable fixes. Inspect provides an external view of the container's runtime configuration, helping you confirm image identity, environment variables, network settings, and storage mappings. When you understand what each of these concepts is for, you can choose the right one for the problem you are trying to solve, and you can explain container behavior in a way that is predictable and exam-ready.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.